Standard for algebra is the understanding polynomials. We're going to be adding, subtracting, multiplying, and dividing stuff. But the one I wanted you to remember is the math practice standard number 6, which is a 10 to precision, right?
Yes.
A 10 to precision. Math practice standard number 6. All right, our objective for today. I can add and subtract polynomials. Let's read together. 1, 2, 3. I can add and subtract polynomials. So if you notice, we're on the same concept, but now we're adding and subtracting. We did a quick introduction yesterday, the day before, and we've been on polynomials for already a couple of days, so you should be a little bit more familiar with them. What are polynomials? We already know what they are. Monomials, or the sum or difference of monomials. I gave you guys examples, non-examples. We know that they are expressions only with various terms. Are we there? All right. Any questions with polynomials? All right. So I have steps. Write these steps down. It's only 4 steps. Number 1, distribute, which means multiply factors to each term inside of the parentheses. Distribute, multiply factors each term inside of the parentheses. Step 2, identify like terms. Step 3, use commutative and associative properties to combine like terms, which means add or subtract. And step 4, simplify. And if you notice, you're going to start noticing that we already did, I think, most of these, right? At the beginning of the year, just with numbers. Remember that? Yeah. When we did addition and subtraction of real numbers, we use these same steps pretty much. Copy those, please. So we had our steps, right? Simple steps, guys. Here it goes. The first step. We distribute if there's anything to be distributed or multiplied inside to each term. Step 2, identify like terms. Very simple. Step 3, we use properties. What kind of properties? The commutative and associative. Step 4, we simplify. Okay? So, polynomials and combining like terms, what is that? Let me show you. The easiest way I can present that is like this. Everybody look up. Let's say I open up a store, and you guys are going to work this for me. Yeah, for extra credit and free homework, right? So, the store, I open up a pet shop, and it's going to be called Original, I thought of an original name, and it's called Mr. Q's Pet Shop. Right? And the phone number is 760 Mr. Q's Pet. It's located at 23rd Street. The address is 2300. Okay. So anyways, so at this pet shop, we sell all kinds of stuff, the food and all the toys and whatever it is for pets. But I only want to sell 3 different types of animals because I don't have a lot of room. So the first type are dogs. Okay. So I have a Siberian Husky and a Poodle. So any kind of dog, I have one of those. We're going to sell dogs. The second type of animal are cats, and the third type are dolphins. All right, so my sister likes dolphins, so I'm going to sell dolphins. All right, and we're going to have also the other thing that we're going to be using there in the store is money. But since we're going to sell whatever we sell has to be to the exact amount, which is exact dollar amount, no longer the $29.95. No, $30. Right? No longer 99 cents for this or that. Yeah, $1. You know why? I don't know why people do that. The 95 or 29.99. Dude, it's $30. That's it. You know. So, anyways, so this is our pet shop, and since I'm going to be away for business, some of you are going to be in charge of the store when you go into to work, right? And some of you are going to want extra credit, so people are going to be volunteering to go in. Yes. Oh, okay. Yeah. Some of you are going to be in there. So, anyways, so the day comes and I say, okay, we're going to open up our store next week, so I need some volunteers to go in and work. So then we get Gustavo that goes in. We got Javier, Hayam, we got Jessica, we got Lucy. And I'm going to put in charge of the store Lucy. And I tell Lucy before I leave, guys, so I tell her, all right, Lucy, when I leave, I'm going to call you because I'm going to send a couple of trucks truckloads of stuff to unload. So to get Hayam and get Jessica to put on some belts, and they're going to be unloading trucks. So therefore, to lift heavy stuff. So anyways, so with that said, we get to say, you know what? I'm going to send 2 trucks. And however, to save pages of writing a lot of stuff and a lot of words to make it faster, I want you to use variables for each type of animal. Okay? So for the dogs, we're gonna label them X. For the cats, we're gonna label them Y. For the dolphins, we're gonna label those X squared. And for the money, it's mainly just a number without any variable. Okay? So therefore, I call and I'm about to give them a heads up, and then Lucy's off. Hello, I'm all, hello. You're supposed to say Mr. Q's Pet Shop. All right, I'm gonna hang up. Mr. Q's Pet Shop. All right, there you go. A lot better. So anyways, so I said, okay, Lucy, the first truck is arriving in a half hour, so get people ready, and then I'm gonna send you a second truck within an hour. Okay, so hang up. And she starts writing stuff down. We get in that truck 7 dogs. So I write what? 7 X. 3 cats. 3 Y. 1 dolphin. 1 X squared. And an envelope with money, and I send her $23. All right. So here we go. So that was in the first truck. They unload it, and all of a sudden here comes the second truck. And then Hayam left to lunch, so Gustavo gets to unload, and Jessica's still unloading. So here we go. So here comes the second truck, and the second truck has 4 dogs. So what do I write? 2 cats, 2 Y, 3 dolphins, 3X squared, and again I send her $23 on an envelope. All right. And then I said, okay, I'm going to call you so you can come up with a total and let me know what is the total amount of inventory we have. So what does she do? She's all, okay, I got this. All right, goes across like that. And this is what? 11 dogs, 5 cats, 4 dolphins, and 46 buckaroonies. So notice what we did. We just added polynomials vertically. Like this, and that's a process that they're going to show you in the book. We usually try and add like combining like terms horizontally. You'll see that right now. But do you see how this works? Any questions with that? Did I ever combine this number with an X? No, because they're totally different animals. I'm sorry, things. This is an animal. This is money. Did I ever combine a dolphin with a cat? No, we just write them out the way they are. Everybody got it? So check this out. So 2 things that you need to pay attention to, like terms. In order for a term to be like one another, they have to have 2 things. Either they are a constant, which is a number without a variable. Check this out. Everybody look up. Look at this polynomial. See if you can find the constant. Got it? So the constant there, what is a constant? A real number, not a variable. Let's see. 35 and -12. Are we there? So now, to go a little bit faster, who remembers what happens when we have to subtract? When we add the opposite of the second to the first? But it's going to take a little bit longer to do that. So to go a little bit faster, I just want you to do this. Circle this, and we know that this is what? -12. Are we there? Okay. So these 2 are alike. So now let's see. Let's look at the variables. Variables of the same kind are variables that have the exact same exponents and same kind of variable. So they need to have 2 things, the same kind of variable and the exact same exponent. So let's see. Look at these. Which terms are alike? Think about it. Okay, first of all, I'm going to start with this 4x. Do you see another one that's like it? Yeah, which is what? The 6. So if these were to be animals, this would be 4 dogs and 6 dogs. Is that correct? And these are what? 8 dolphins, and then take away 5 dolphins. So those are alike. Okay? So the process that I gave you, the steps. Step 1, you multiply. Are there any things to multiply? No. Step 2, identify like terms. So we already identified them, right? Step 3, commutative and associative property. So this becomes 8x squared. What else? Minus 5x squared. And then we get plus 4x plus 6x. And then plus 35 minus 12. That was commutative. What is this one? Associative. So this becomes 3x squared plus 10x plus 23, Michael Jordan. So notice that we can combine once you get our properties in place. Are we there? This is example Q. Copy this, please. Only this piece right here. Use your colors, please. No, that's the summary in the back. All right, here we go. So, any questions with combining like terms? So the steps were, number 1, multiply. There wasn't anything that distribute. Step 2, identify like terms. Did we identify the like terms? Yes. Step 3, commutative and associative property. Yes. And step 4, simplify. Are we there? Okay, copy these down, please. Example 1A and 1B. Okay, and it says 1, add, subtract, and for A, it's 12p cubed plus 11p squared plus 8p cubed. Let's do this one together. Here we go. So you wrote add or subtract, and then A is 12p cubed plus 11p squared plus 8p cubed. All right? So first things first. Do we have anything to distribute or to multiply? Nope. Can we identify like terms? Yes. So I'm going to circle this one. Is there another one with the same variable, exact same exponents? Yes. So why circle this one? I already identified it. Okay. Step 3, use commutative property. So I'm going to write these down together. 12p cubed plus, what else? 8p cubed. And I bring down the other one, 11p squared. What's the other property? Associative. So what is 12p cubed plus 8p cubed? 20p cubed. And I just bring the other one down. That's 11p squared. And I'm done. Why can I not combine these two anymore? Because this one has a totally different exponent. Remember, they need to have the exact same variable with the exact same exponent. Have you got it? Yeah. Okay. Do this one by yourself. See what you get. Okay, here we go. So, first things first. Nothing to distribute, so I'm going to identify my like terms. Let's see. Do I have another x squared? No, so I just bring that down here. 5x squared. And then I'm going to go next with the next variable, this one. Do I have another x anywhere? No, so I just write it here, negative 3x. And then do I have another constant? Yes, these two. So what is 8 minus 6? 2, and I'm done. Can we combine anything else? Can we combine anything else? No, right? Because this is a total different animal than this one. If this was a pet store, this was 5 dolphins, right? And I owe somebody 3 dogs, and I have $2 in the register. Does that make sense? Huh? Because somebody took my other $21 to make it 23. All right. So here go 2 more. Copy these, please. See if you can do these by yourself. Go. Okay, let's see what we got. Here we look up. So, first things first. Is there anything to distribute? No. Identify each like term. This is the first one, and is there another t squared? Yes, right here. And what is the invisible number here? 1. So, 1 minus 4, that's negative 3t squared. I skipped a step, right? The commutative where I wrote them together. Next, 2s squared and negative 1s squared. Is that correct?
Yeah.
So what is 2 minus 1? 1 positive, so it's 1s squared, or without the 1. Hands if you got that by yourself. Okay, good. Okay. Next, let's go with this one. Let's see. M squared n. Is there another one that has m squared n? Yes. Is there another one? Yes. So they're all the same, so I don't really need to use the commutative property, right? However, I can associate these two because these are positive. What is 10 plus 4? 14 minus 8, 6 m squared n. And we're done. Hands if you got that. Okay? So far so good? All right, check this out. I'm going to flash 2 more. You don't have to copy these. Do them in your noodle, and I'm going to see if you got them right. Here we go. Look at these. Okay? Don't say it out loud. Keep it to yourself. First one, 2s squared plus 3s squared plus s. Okay? You got it? Okay, let's see if you thought this. The correct answer is 5s squared plus s. Okay, that is correct because these are the ones that have the exact same exponent, same variable. Look at this one. Let's see if you get the same thing as I do. Correct answer is 20z to the 4th minus 6. Everybody see that? Okay, so that's pretty much combining like terms. However, everybody look up, please. When you get to these, hold on, not those. In a second. These. Pens down, please. Eyes up here. This is the same thing that we were doing earlier, but now they're grouping them together. So, first things first. Do they have, notice that this is addition. Are we there? Do we have a number here? No. How about here? No. If it's addition and both parentheses do not have a negative sign or a number in front of them, rewrite it like this. 4m squared plus 5 plus m squared minus m plus 6. What did I just do? I took away the what? Parentheses. Let me show you why I take away the parentheses. There's an invisible number here, which is a 1. What is 1 times m squared? M squared. What is 1 times negative m? Negative m. 1 times positive 6? Positive 6. Same thing over here. Is that correct? Hold on. Pay attention. So, do we know what to do from here? Yeah. So, let's see if you can see it. Everybody look up. What do I write first? 5m squared. And I'm going to go with the next one, which is minus m. And then plus 11. Are we there? Okay. Now, hold on. One last thing. My bad. Hold on. Give me a second. Check this out. But what if they give us, oh, I already talked about vertical addition like this, right? With a pet shop. You know how we add like that? Okay. But what if they give us this next one, which is a subtraction? Pens down, please. Eyes up here. Look at this. What did we do at the very beginning of the year when we have subtraction? We need to do what? Add the... So what is the opposite of this one? Negative 5m to the 4th. And this one is a negative, becomes a positive 5m squared. This one becomes a negative 8. You see how what that happened? I just bring this down. Okay, and that's pretty much the homework. So, check this out. Homework is found on page 441, numbers 1 through 15 all. Okay? Now, guys, there's no tuning today. I have a meeting, but enjoy your homework. Have a good one. Oh, sorry, before I forget, your progress boards. Here we go.